Hello and good morning, good afternoon and good evening. Thanks for joining us today for this third last webinar in our series of Tungsten MySQL use case webinars. I'm joined by my colleague and our founder and CEO Eero Teerikorpi, who's presenting today on the topic of AWS Aurora MySQL and replacement of same. We'll be going through a presentation, of course, and there's always also going to be a live demonstration. You'll see that of our Tungsten dashboard product, and we are happy to have you with us. But for now, I'll hand over to you, Eero, for today's presentation.
Sounds good. Thank you. Hello, this is Eero Teerikorpi. As indicated, I'm founder and CEO of Continuent. And today I'm joining you guys from my home office. This is in San Francisco Bay Area. And in the background, you can see a view from my window. And as you have noticed that California is burning, so we have had quite a bit of smoke also lingering around us. Today is a pretty interesting topic. This is a customer who chose to replace AWS Aurora with the Tungsten clustering solution. And we will go through and step through why they chose that route. Continuent, as you may know, is all about availability. Our tagline is MySQL availability company. It started from the kind of providing a continuous operation for business critical MySQL application back in 2004. And we've stuck on that route ever since. An ARTIK use case, it is about the geographic scaling a software as a service application. This is a IoT platform, idea of providing a secure platform to collect information from various IoT devices distributed and operating across the globe. And being able to collect that locally is pretty significant requirement. And this is one of the key courses that why ARTIK chose Continuent. And full disclosure, assumption ARTIK as a software as a service offering effectively failed. It's no longer operational, but the use case still is quite valid and it kind of applies to any and all other similar use cases that they may want to deploy at global scale. A couple words of myself before we get started. So what qualifies me to talk about MySQL, MySQL Marketplace, MySQL solutions? I've been around some time. On MySQL Marketplace specifically since early 2000, very beginning of the MySQL, we saw the opportunity to build something that we believe that the internet and cloud will be big, as well as the open source databases. And we chose to offer a highly available MySQL backend pretty early on. You may call me a father of Tungsten. Tungsten is the key product Continuent offers, but also one could call me a godfather of Kalera. You may have heard about Kalera or XtraDB cluster or what other names is available. Kalera is effectively based on Continuent's first solution. We had a M cluster for MySQL back in 2004 on until 2007, but we didn't believe that could scale as well as our current solution. So we abandoned the M cluster at the time for the benefit of the Tungsten effectively. And the team behind M cluster chose to continue their development work and came out with the Kalera, which is a great solution for what it meant to be, the local availability solution, not necessarily a global backend for the business critical MySQL solutions. And as you can see from my picture, I'm also a sailor officer actually from a Finnish Navy. I'm a native Finn and been living in California past 30 years actually. But my favorite pastime is to be on San Francisco Bay sailing. And I also like to apply similar approach on my business, running a tight ship for the benefit of our customers. So you'll hear a little bit more about that down the road. So where do we as a Continuent fit in this marketplace as a whole. Yes, we've been around quite some time, and it was pretty brave to focus on open source and cloud computing in 2004, and specifically focusing on the business critical end. At the time, MySQL was pretty niche solution, not very capable solution, but it has grown over the years significantly. But we felt that that was an avenue to build excellent e-commerce and other internet web-based applications. Then our bet was right. We've seen a significant growth on MySQL market, and we wanted to build something that actually runs and operates on premises. That was the predominantly fact 2004, and it should run in the cloud as well, and as we do today, and we did from the day one actually. And it is about being able to provide clustered solution for the business critical application based on MySQL database. Continuing, we do not aim to be the biggest company in this marketplace, and it's never been our goal, but we want to be by far the best, and that's always what we want to do and continue to do, and we saw how we excel with this goal. ARTIK use case, Internet of Things, devices that has intelligence, that they collect all kind of information, and then in order for this information to be kind of valuable, you need to consolidate that and run various kind of analytics and reports. And this is what the ARTIK was building and providing effectively secure backend for the millions of worldwide devices. And then real question, why would Samsung large telco entity choose Continuent, which is a relatively small player on the software realm, especially when they were considering replacing something that was running perfectly well in Amazon AWS environment? Was it about availability? Was it about disaster recovery? Possibly geographic scaling or cost? Or maybe it was all of the above. And the answer, like with many our customer cases, it tends to be all of the above. But that wasn't the key driver, actually. So the key driver was geographic scaling. And whenever you offer a global solution, whether it's a software as a service or e-commerce, telecommunication solution, financial services solution, or maybe gaming solutions like our customer Riot, geographic scale is important. And you can do it in a couple of ways. But when you want to have a solution that enables updating close to the region that your application operates, you need to have a multi-primary geographically distributed solution. And that's just not something that the AWS and AWS Aurora specifically offers. Clearly, there are elements about the high availability as well, and continuous operation. Continuous operation is not only about losing a database, it's also how you deal with the maintenance windows, and can you actually do zero downtime maintenance like we offer or not. It also includes the element of the possible disaster and how to recover and how to provide continuous operation when you lose the whole data center. Maybe you lose a region. And it's not as uncommon event as we would like it to be. And more recently, there has been even more challenges because there are all kind of events playing havoc worldwide. And there is a significant risk losing specific region or data center, yet operation on the 24/7 environment should continue. And then last but not least is always the cost consideration. How do we build something that is reaching the global audience yet still being cost effective? Aurora Limitations, and the first one was the biggest one for the Samsung question. It really allows to have a primary database in a single region only. And that's in order to build a solution that reaches the geographic audience and can update the data worldwide is a significant limitation. Obviously, there are host other things that we will dwell a little bit deeper as we go along. When we looked at from a kind of a head-to-head comparison, Aurora and Tungsten, there are some elements on the providing local high availability. AWS Aurora is pretty good on that. It's a great solution, easy to deploy. It's a database as a service. Almost, they call it managed database as a service, but in reality, DBAs are required. So that the notion of the managed service is somewhat limited. But when we step kind of further on the requirement list, disaster recovery, continuous solution is excellent on that. We can discuss about how we do it. Then AWS Aurora is already showing some of the limitations. And it's not automatic, fast. It is a failover that takes few minutes. Actually, the few minutes may end up being 30 minutes. If your business allows that, fine. If not, you may end up losing a lot of revenue or many customers by not being able to do disaster recovery properly. Load balancing, that's one of the areas that the continuous solution shines with our Tungsten proxy solution. Proxies have been introduced as a part of the Aurora and other databases, but they are not fully integrated as in Continuent Tungsten Cluster solution. Is that they effectively cluster management and proxy and continuous solution are talking actively with each other, and they know quite a bit about the backend, which allows them to make a far more intelligent and faster decision. Downtime during the maintenance, covered by Tungsten, not so much AWS Aurora. It always requires a downtime. Then we go in more specifically, this thinking about the performance. Both solutions have a high performance. In some cases, to be honest, AWS Aurora has even higher performance for the specific type of workloads compared to our solution. But in general, we meet or beat Aurora in most typical use cases. If you have a really high volume, small update type of traffic, Aurora may be a better solution than what we offer. Transparency, this is kind of interesting. How do we operate the failover situation and how transparent that is from the application point of view? Not so with the Aurora, because the applications effectively get disconnected during the failover process. Transparency is also about the SQL transparency. We can discuss about that separately, how well your application behaves, because effectively we run on MySQL and AWS Aurora is MySQL compatible, which is an onset of an issue. Deployment, both can be deployed in a matter of minutes in the cloud, so there's no big difference there. Recovery, both can provide you a pretty easy recovery process, but when you have a cross region on AWS, that actually will take time, and it's ultimately outage. And then going back in a kind of even further in these comparison items, monitoring, we both have a nice graphical UI, although our UI is free of charge, included a part of the solution, and in AWS you have to pay extra for that benefit. We have a pretty extensive set of monitoring based on some open source tools available on the performance monitoring and management. So in that case, actually, we once again exceed capability of Aurora. And then specifically an ARTIK use case, Geo-Scale. That's our bread and butter, really where we shine. And this is where most other application database as a service solutions offered are failing quite miserably. There are claims to patch things together, but we actually do this out of boxes by design. We do have another few elements that makes us a better solution. Tungsten Replicator, which is part of our clustering solution, is not only a homogeneous replication solution, it provides also ability to heterogeneously replicate into various targets. It could be another database like MySQL, Postgres, Oracle. It could be a reporting. It could be analytics. It could be a data lake. And this is part of the integrated solution that you can do from Tungsten clustering, not so much in the AWS environment. And last but not least is that our amazing support. Over the past 2 years, across all of our customers, our initial response time has been less than 3 minutes for all customers in urgent support tickets. We understand that our customers are running business critical applications. We want and need to be available to provide continuous operation. When you are dealing with any other DPS solution, the basic support may be available via email or the web portals. In our case, it's actually the human interaction directly initiated by our experienced team members. And if you want to have something even closely similar, even that would match our ability to, for the response time or the knowledge, you have to pay a lot of money for the AWS support. Just the things to consider. And here are a little bit kind of a summary of these items. Let's not fall too deep on this one, but it's available on the slide and you can study at your own pace as you feel. So ARTIK main challenge was effective geographic scaling. When they started and built their application, it was running on AWS environment in single region, and basically effectively was a proof of concept test environment. But when they were ready for the global deployment of the solution, then the realization came that they just couldn't get it done easily or at all and cost effectively using the tools available at the AWS, whether it's RDS or Aurora. And it gave us an opening to provide. And this is kind of a deployment model that many of our customers have. They may have a couple data centers or cloud deployments in US, one in Europe, one in Asia Pacific, often in Singapore. And in this case, this is multi-primary, so that we have a multiple primary databases in each of these regions, being able to update data locally. One can also deploy this active passive model depending on if the update volume is relatively low, like in Riot Games point of view. So they have a solution that they have one single primary in US West, and then they have a local passive clusters in US East, Europe, and Asia Pacific, providing a kind of the game players access to the game playing, effectively account management, a host of other applications. So it kind of gives a flexibility depending on what you need to emphasize. It is about the local reads or it's about local updates, and you can build the backend accordingly. And availability, that's most of our customers start from this point of view, while ARTIK was more about geographic scaling, continuous availability is always the primary concern for the software as a service entity. And our approach this is they have built a database cluster. And then when you have these clusters, then you can build what we call composite cluster, a cluster of clusters, and providing a geographic reach. But each unit starts typically with the component of the 3-node cluster. We have a one primary, and we have a 2 or more replicas, depending on how much of the pre-traffic locally is. And then there's 3 main components that they're managing this. Obviously, there's the replicator. Tungsten replicator is the most advanced replication engine for the MySQL marketplace, both homogeneous and heterogeneous needs, and that's built in as a part of the cluster. Tungsten manager effectively is the element that orchestrates, makes the decisions, business rules-based decision, how to behave in certain situations. For example, if there's a primary failure, how do we promote the replica as a new primary? Or if you do a maintenance, rolling upgrades, updates, manager is the one that manages those events. And manager is actively talking with the Tungsten proxy, also known as a Tungsten connector for our customers for historical reasons. Tungsten proxy is an intelligent traffic cop that guides the traffic based on the role of the databases in the cluster. And not only guides, but it also can make changes on the fly. So that it has a load balancing capability, but it also have an ability to inject additional information in the traffic stream. So this creates the basic component of the Tungsten clustering, a single cluster. And then when you build a continuous operation solution, covering also this disaster recovery and local update traffic, then you can have two or more of these clusters, either in active, passive, or like in this case, active role. So, and Tungsten connectors in this type of environment are not only locally aware, they are globally aware. So each connector knows the basically deployment topology, what's in a local cluster, and they can also see and communicate information about the global view of the cluster, how many members are in each cluster and what are their roles, so they can guide the traffic accordingly in the right place. And then there's a cross-site replication between all of these clusters. In this case, when we have 3 primary environments that allows us to then, using Tungsten Replicator, update information in each of the other respecting region, almost real time. Obviously, depending on the distance between the clusters, there is some latency of the update, and also the size of the transaction and the number of transactions applies that what the latency between the sites are, but it's still relatively low. All of this replication is asynchronous by design. It allows them to have these loosely coupled clusters to continue operating even if you lose a member within a cluster, or if you lose a member in the cluster of clusters. And then these clusters can catch up, or the node can catch up when they come back alive. This type of design allows effectively 24/7, 365 continuous operation for the system. And as an example, one of our customers, they had a significant event in South China Sea. There was a typhoon basically damaging the big internet artery and local, and effectively took the whole region out of the picture, yet they were able to continue operation without any hiccup from the user point of view. Which is kind of, once again, an amazing testimony how well this worked, and without any human intervention actually on that case. This is a graphical user interface that allows us to manage these clusters. Can I give you a view, in this case, that the 3 clusters, one in US West, one in US East, one in European area. And when we kind of open it up, you can see that the actual members of the clusters, and also that all the replication links between the clusters, because this is the multi-primary deployment, it becomes a pretty sophisticated, I guess. Maybe you can use the term complex, but from the actually management point of view, it's not too complex at all. So let's go take a look this in real life. So this is the whole cluster, and it's actively running. This is what we do with most of our customers. We built this at the identical deployment environment in the cloud, so we are ready to help them and diagnose, and also support them. This is obviously not the production cluster, but it effectively mimics the production environment. And if you look at the closer, we can see that the members of each of these cluster. So let's go US West, for example, and we have here database 4 is the local primary, and we have 2 replicas in US West, and we can go in US East. Database 1 here is the local primary. And if there were any type of a failure event, let's see if we would replicate a failure to kind of I will shut down database 1 and come here. Is a refresh rate is here. As we can see, there's a whole lot of red and yellow indication that something just happened, and now Tungsten proxy and Tungsten manager are working in concert together. Both Europe and US West are still active and servicing the customers and users. Also, if effectively US East is doing that, it's only kind of there's one database is completely out of the activity, and we are now promoting a database tree to become a new primary. And then we work the magic, the connecting all the needed replication links back in active mode. So this goes through the pretty complex or sophisticated process, providing and basically effectively a active solution again, -1 database. But during this process, most connections stayed open. Obviously, the one database that failed, any connection to that particular database were severe. But since proxy was in between this database and the cluster, from the application point of view, there was no disconnect. He just rerouted those connections to the new database, in this case, database 3. And effectively, from a user point of view, it was a continuous operation event, even if he just lost one of the databases. We can quite easily bring this database back if there was no physical harm, that there's no real issue on the database. We can just execute the recovery process so that effectively bringing this database back in the cluster. The process is that we will restart the MySQL. We basically run the catch-up process, that any transactions that did take place during the downtime will be applied to this particular database, and when it caught up close enough with the local primary database 3, it will be introduced back as a full cluster member. I didn't have a refresh on, so let's put that on. And once again, this is pretty sophisticated process, and we have a quite complex topology, so it takes a little bit of time to get this database back in action. But do remember, while we are doing this in automated fashion, all the other application database are effectively working actively and providing a service. And yes, success. Now the cluster is once again fully operational on 3 geographic sites. All the replication links are re-established. And once again, it didn't require a lot of deep technical knowledge in order to operate this cluster. So you can effectively do this during the normal business hours, during the operation. You may want to shy away from running and these type of processes at peak season or peak times of the day. But in reality, most of our customers keep doing that day in, day out without much of a hesitation, because all in all, the cluster works really well. All right, let's go back in our presentation. The last one we discussed about is obviously the cost challenge. That whenever we are dealing with using open source databases, our customers have a high cost consideration to start with, and then alternative would be running an Oracle database or SQL Server or some other commercial database, but it's pretty expensive as a sense. Also, the AWS managed database as a service ends up being quite expensive proposition. What we are doing at Continuent is that we have a solution that has an annual subscription. It includes the software and 24/7 support with very fast response times. And initial cluster, yes, it's somewhat pricey, but not expensive compared to considering that all the services you get in as a process. But as the system grows, the more clusters you deploy, we realize that the increased and additional value we add in the customer's deployment, it comes less and less. So does our pricing per node comes effectively almost no significant increase as the node count rises. We have customers running hundreds of clusters. Some customers have like one particular large customer has 1,000 clustered MySQL databases, and on top of that, an additional 1,000 replication instances feeding into various reporting and web applications from those services. And we have another customers that have a significant large terabyte size of a database backend and hundreds of clusters as well, providing marketing analytics, for example. So as a recap, yes, it was about availability, ability to do the disaster recovery. Predominantly, the initial reason why Samsung approached us was about the geographic scaling. And then on top of that, they got the cost benefit and amazing 24/7 support with the really fast response times. Quick rundown, the solution Continuent offers. Tungsten clustering obviously is the one that we've been talking about during this webinar and in this context. And it is about the ability to do this geographically scaling MySQL backends for business critical applications. It's about the continuous operation, zero downtime, ability to distribute, run in the multiple environments. You can do it on premises, you can do it in the cloud, you can do it in a multi-cloud deployment. Some of our customers actually have run both AWS and Azure side by side. We have customers who run some part of the application on premises and other part of it in the cloud. So it's actually hybrid cloud, and this can be used for the migration needs. If you already have an on-premise application you want to move into cloud, you can do that without downtime. Or you can have a continuous operation between hybrid cloud instances. And this is a full MySQL solution. It's not about MySQL compatible, so there's no application changes needed and required using our solution. And then going in deeper on the key benefits, what we offer, you may find it interesting that we start with the first key benefit is the support. But this is what we value really highly. And this is something that our customers value even higher. The fact that you have a really knowledgeable DPA or site reliability engineer available, you at minutes notice, is amazing additional extension and expansion of your existing DPA team. We do not offer remote DPA services. That's not our business, but we definitely augment that with our knowledgeable team, and we can provide also guidance on your MySQL related issues. But our main focus is obviously availability and our own solution. And then cost savings. This is other thing that we want to emphasize. Even if our solution is commercial solution in open source real, in many ways our pricing model is modeled after open source mindset. And when you have this type of a complete solution without need to patch things together, you have something that actually works out of box. It's really easy to deploy and support and maintain. It does reduce time required by DPAs to manage the database backend, which is effectively becomes a really highly cost. Some of our deployments, when we have hundreds of clusters, would not require more than a couple DPAs actually run them day-to-day operation. And then obviously the deeper level, it is about the continuous operation. I won't go on the detail in each of these here, but you get the drift what this solution is about. It's about availability and being able to run maintenance operations while systems are up and running. It is about scaling and running in multiple environments. It is about providing an amazing proxy to manage traffic between the applications and the database backend, providing these extra tools like a query inspection and other things that allows us to have a higher performance solution. And this is also the intelligence that keeps application and active users not disconnecting from a MySQL when there is a failover event. And then obviously there is this replication capability, which is pretty amazing. We'll discuss about that a little bit separately. This is not about the MySQL compatible solution like AWS is. It is a full MySQL. Not only MySQL, it's actually also MariaDB and a Percona server, so that you get the full benefit of all the development in open source communities around MySQL. We support all versions up and down so that and this is highly secure environment. All the communication is secure in flight, and also that there is a ability to encrypt the actual data of the databases. The replicator, we referred, it is a core component of the clustering, providing the service for the cluster members, but it also is a solution for the heterogeneous replication. So you can actually extract data from a single MySQL database or MariaDB or any other MySQL variant and replicate that into various heterogeneous targets. It could be a Aurora instance, it could be a Redshift, Vertica, Hadoop, Kafka, and a host of others available. We have a pretty extensive topology support, being able to fan in, fan out, and you can use that for the multi-primary replication as well. And this not only is just a kind of one-to-one replication, we have an extensive capability to filtering and also the obfuscation of the data in flight, so that it can be used in various special purpose cases as well. And this, as well as the clustering, is available as an AMI in AWS environment. So if anybody wants to kick tires or actually deploy a production great solution using the tools in the cloud. And then you already saw Tungsten Dashboard. This is the graphical user interface managing our clusters, ultimately also our replications and tools. And then this is not charged, it's available. You don't have to use it. We have also a command line interface and API, so you can access all the functionality through those two, but those more comfortable managing, like myself, through the graphical interface, this is an excellent additional tool. Question. Would be interesting to know if you are looking actively a solution. Is this something that you already have something in place, but you're not particularly happy about it? Or is this something that you are just curious, you already have something in place and you are happy with? All of these cases, feel free to reach out to us and see if there's something how we could help you. And even if this is not right now something that you're actively looking in the future plans, great, will be available. We've been around since 2004 and we intend to be around down the road. So let us know when you are ready and we are ready. And education is always good, so no worries. We are happy that you took the time and listened in. Couple words about the Continuent and Continuent team. So we've been around, as I said, since day one of MySQL and really building data availability solutions. So for the 2004, we have a unique team. It's an expert team of the data replication, connectivity, and cluster management specialist. We don't have much of a sales and marketing people. So actually, I don't have any salesperson currently in our team. So that all the commercial engagement, I'd like to be actively involved. And we believe not selling, we believe that educating, and we believe that providing an excellent tool. So that if and when you are interested in our solution, you end up talking with somebody who has in-depth experience on the data replication, connectivity, and cluster management, so that we can almost immediately say whether we are a good fit for your solution. We are not biased towards our own solution. We know them all, and we can easily guide you right direction. In many cases, we may be a good solution. And if you conclude that's the case, we are happy to help you. And once again, it is pretty amazing that we can provide amazing support for our customers, but that's also speaks loudly about two things. Our software actually does work as advertised. It is really robust, and it is highly available solution, and it doesn't create problems by itself. And also, we actually end up dealing with the pretty high-end customers that they have a good understanding of their needs and requirements, and they do run tight shops on their end, which allows us to be helping them as needed, as fast as we are. And here are a few of our customers that get the idea. Most of our customers, some 70% of our customers, are software as a service vendors. We have a number of e-commerce customers, like NetApp Order has a kind of interesting deployment. for the clothing. It's a kind of a lot of e-commerce sites, a few tens altogether behind Net-a-Porter, but that's a separate issue. There was another earlier webinar we discussed about their use case. And Carfax, you know, it's a significant e-commerce front end about the used cars and vehicle history information. They are one of the biggest deployments we have. We also have a number of financial services and telecommunication customers, as well as like Riot Games gaming companies that have a, you know, like Riot Games, hundreds of millions of game players worldwide accessing their player accounts through Continuent powered data services. Would be interested in including you on this list of prestige customers. So feel free to contact us and we will help. Couple more data points about the Continuent, why anybody should consider using the most recent customer satisfaction survey. We get the 100% satisfaction. I'm sure we can do still a lot things better, but the fact that with the current operational level, we get this type of satisfaction is amazing. And we can rate this on a different point of view. So what is the customer renewal rate? It's actually amazing, almost 100% as well. Obviously, there are cases that the businesses are being sold, and some cases that leads to use of whatever the system the buyer may have. But in most of the cases, actually, even this, which is quite frequent event among our customer base, they keep using our solution. And sometimes businesses do fail. In this case, obviously, we lose a customer. But all in all, typical average customer's lifespan is actually close to 8 years now than 7. And we do expect that whoever joins us as a customer, they are with us long term. And we are customers already over 10 years. We are happy to kind of keep them happy over the years as well. So as a recap, it is about MySQL availability. We've been around. We focus on software as a service, e-commerce, financial services, telecommunication, online gaming type of application. We do have enterprise customers as well, like the VMware is one of the big customer of ours. They actually, interestingly enough, acquired Continuent Operation back in 2014. And when VMware was actively pushing their own cloud initiative, vCloud Air, and our goal was to build the database as a service for the vCloud Air. Subsequently, VMware chose a different strategy. Instead of competing against AWS, Azure, and Google, they chose to add value-added components on top of that, which I think it was a better strategy for VMware. But at that point, whatever Continuent was about to bring in the VMware environment was concluded that they're not being a fit anymore. So that's we spun out Continuent as an independent operation again back in 2016. We were happy to be acquired VMware because it's a qualified and solidified as the fact that the Continuent is the best team, the best technology in the MySQL marketplace to provide the solutions we offer. But we are even happier to be independent entity again, servicing our existing customers. And we continue to be here. Our future, in many ways, it's today already, is in the cloud. Over 70%, maybe over 80% of our deployments today are already running in the cloud. But obviously there is a level of service we could increase, automation and other tools, kind of automated deployments, automated management, automated monitoring capability as a full-fledged managed database as a service solution. So that's something that we have been actively working on, and we will bring in the market. But in the meantime, we have an excellent solution already today to compete easily against the existing DBE as a service solution on the marketplace, like we did with this Samsung use case. So, JJ, did we have any questions during this webinar?
There was just one question that came up earlier, Eero, as you were talking about our proxy, Tungsten proxy. And just if you could elaborate a bit more on that, because the person asking hadn't heard about our proxy before, so they were interested in just hearing a little bit more about it.
Correct. Yeah, proxies are really useful tools, and there are some solutions like available today on the open source marketplace. And how Tungsten proxy separates from these is the fact that it's not necessarily only a standalone proxy, but it also has an active communication with the Tungsten manager, or you can think about like a proxy SQL and orchestrator, the open source tools available in the marketplace, but those are pretty loosely coupled, so they actually are not actively aware of each other. But the way we have built our Tungsten clustering solution, proxy and Tungsten manager are actively talking to each other, so that so one level, the proxy functionality built in the Tungsten proxy is greater than any other proxy solution on the MySQL marketplace today, with the tools and services, load balancing, and ability to kind of read the traffic on the fly and making decision. So it could be a port-based, it could be also if the application give hints whether it's an update or read, we can route the traffic, and there's a number of load balancing algorithms available. But then on top of that, the Tungsten proxy through Tungsten manager has a visibility who is in which role within a cluster, which database is primary, which one are the replicas, and how far behind they may be from the primary database, for example, the replica. So we can stop the traffic on specific replica for a while, just to be able to enable it catching up. And then when and if there is a change in the cluster configuration, for example, the failure event or maintenance event, manager sends an indication to proxy, and proxy will stop the traffic, oncoming traffic, for a while, effectively puts in the hold. And then when the reconfiguration has taken place, the cluster continues actively, and then proxy enables the traffic again. So there's a layer of the additional intelligence, but that's not proxy alone. It comes along with it when you are using Tungsten manager along with the proxy. Hopefully that answers the question.
Great. Yes, thanks, Eero. And I think it's the only question we've received for today. So we can probably wrap up. And if you have some closing words, Eero, I think it would be great to hear them now.
Thanks, JJ, and thank you for the audience. It was my pleasure to talk about Tungsten clustering solution, and in this case, in context of the why somebody using AWS Aurora should and could consider our solution instead. And we are available. You can reach out through our website, continuent.com, or sending email, sales@continuent.com. As indicated, there is no salesperson going to reply you, but we will definitely reply you, so that we will establish a deep dialogue on the technical merits instead of a hard sell. So we look forward working with you down the road. Thank you. Have a great rest of the day. Bye now.